It is 1:30, so it's time to start. Welcome to this talk about Blazor, about single-page app revolution with WebAssembly and ASP.NET Blazor. My name is Stropek, and in the next 60 minutes we are going to explore this Blazor stuff by building an application step by step. I've prepared a lot of pre-baked code, so I will not write that much code. We'll copy code in step by step. And with every step, I will show you some ideas of Blazor, and I will describe what makes Blazor unique, where the advantages are, and where the disadvantages are. If you would like to keep in touch with me, you can go there, stropek.me, that's my virtual business card, and in the right lower corner you see a lot of links, for instance to LinkedIn, to GitHub, to YouTube and so on. By the way, YouTube, I'm maintaining a pretty active YouTube channel. I will also record this session, so if you want to rewatch it or show it to some colleagues, it will be made available for free in the next few days on my YouTube channel. You will find other Blazor talks there too. Good. So with that, let's get started, and this is a developer session, so we will get started immediately in Visual Studio. I've set up a rather empty project. It's not completely empty. Let me quickly show you what this project is all about. It's nearly File New Project Blazor app, but only nearly. Let me show you what this project consists of. First, as you can see it here, it contains an API. This is a RESTful web API, and our goal is to build a front end, a web front end for a starship travel agency. So it will be possible to buy tickets flying from Earth to Krypton or from Tatooine to wherever you want to go to. And this is the backend API for it. The next one, this one, is the client application, and this is where Blazor lives. This is the Blazor application, which is compiled to WebAssembly or not. We will take a look at that, whether it's really compiled to WebAssembly. Then I would like to have a reusable class library where we put all our user interface components into it, and that's a regular .NET standard DLL. Why am I creating a .NET standard DLL? It's a Razor library at the end of the day. Because I would like to reuse these components. I would like to demonstrate how easy it is to create a reusable library for a single-page app. Any, let's say, Angular developers in the room? Have you ever tried to create a reusable library in an Angular project that is shared between multiple projects? It's possible, no question about that. It's got much easier in the last versions of the Angular CLI, but still, it's a pain. And with Visual Studio and .NET and Blazor, that is really one of the strengths. Building reusable libraries, reusing existing code is really one of the strengths here. And finally, I have one class library here, which contains the modal and a little bit of the business logic. Sorry that I called it modal. It should be called modal and business logic. But yeah, I didn't rename it because I was lazy. Yeah, but it will contain modal and business logic. So this is the structure of the application. And before we talk anything more about that, let's run this application. It's impressive from the very beginning. That's the application. That's all it does. So let's take a look behind the scenes. Let's press F12 and go into the Chrome's developer tools. Here they are. Let's take a look at the network and let's reload this guy. Good. Okay, we have one error. It's just the favorite icon. I didn't add the favorite icon. And what you immediately see is some very interesting loading that's going on here. A little bit of HTML and CSS and JPEGs and so on. But here it's getting really interesting, and that's the whole idea of Blazor. You see, the system is loading mono. Yes, we get the mono runtime, not the core CLR, the mono runtime in the browser. What essentially the core idea of Blazor was back in 2017, some guys thought, hey, browsers can run C++ using WebAssembly without any plugins, so that's not a new Silverlight, to make this one very clear. Yeah, I've done my share of Silverlight development and I have regretted it, so I don't want to have a new Silverlight. It's plugin free, but it can run C++ code, and the common language runtime for .NET is written in what language? C++. So why not just taking the C# common language runtime, compile it to WebAssembly, and run .NET in the browser? Well, it isn't that trivial, granted, but the core idea was exactly that. And they did that. The result is Mono. Mono.wasm. That's the common language runtime compiled to WebAssembly. And that's the only thing currently that is compiled to WebAssembly. Your C# code is, and I want to emphasize that, not compiled to WebAssembly. So if somebody tells you that Blazor is a framework for compiling C# into WebAssembly, that's wrong. What you get with Blazor, or to be more specific, with Mono, is you get a common language runtime running in the browser, and this common language runtime can then run .NET standard DLLs. Because that is what's going on behind the scenes, as you can see here. We are just loading a bunch of DLLs. That's the DLLs that you know and love. That's .NET standard. So we are really running .NET in the browser, and from there on, it's just intermediate language. Is it compiled maybe by the jitter into WebAssembly? No, that's not the case. In the browser, your intermediate language is interpreted. That's the interpretation mode of Mono running your intermediate language here. Okay? That's important. And then we're downloading a bunch of DLLs and we're calling into it. Now, if that's all that is to say about Blazor, that wouldn't be enough. Because if we take a look up here, then we will find some interesting stuff. For instance here, blazor.webassembly.javascript. So Blazor is not only about WebAssembly, it's also about JavaScript. Why? Now, listen closely. In WebAssembly today, an application cannot communicate with the outside world through the DOM. From WebAssembly, you cannot manipulate the document object model, so you cannot paint pixels on the screen. It's not possible. If you would like to communicate with the outside world, doing a web request or drawing something on the screen, you have to go through JavaScript. And this is where Blazor comes in. So Mono is caring for running C#. And Blazor is really adding the single-page-app framework on top of it. Blazor is standing there waiting for some signals, some messages coming out of WebAssembly to maybe display a combo box or a button or an input field or whatever. This is what Blazor is all about. Okay? For those of you who are familiar with other web technologies, Angular for instance, TypeScript would be the language, JavaScript would be the runtime, very similar to Mono here, and the framework, Angular or React or Vue, this would be Blazor. Okay? So Blazor is really a single-page app framework, and Mono is caring for bringing C# into the browser. Good? Fair? Good. So this is what's going on, and currently this does exactly nothing. So let's add a little bit of more interesting stuff. Let's make this a little bit smaller, and let's stop this guy here, and let's go to the components section here. I have my first step, and copy a Razor page into my component section. Let's open it up. Let's rebuild the entire solution. And before we look at the code in more details, let's run this guy. Still compiling. Takes a few seconds. By the way, I'm using the latest preview bits here. I updated literally today in the morning. So this is not running the final bits, it's really running the latest preview bits. So things can go horribly wrong, maybe. We'll see. So let's run this guy now. Good. And you see, we get some data back. Your tickets, and if we take a look, Mr. Optimus Prime, Mr. Bumblebee, and Mr. Kal-El is traveling with our space agency. So let's take a look what these guys did and how we got them. Let me introduce you to Razor. Razor is the language for writing UI components with Blazor. Some of the things that are currently on the screen, I will not even mention that because I think you can guess it from the context. You see that you have a router with the add page directive at the beginning. You have dependency injection. Yes, we can inject an HTTP client. That is exactly the HTTP client that you know and love. That's the HTTP client that you have been using for many, many years, and we have it available in Blazor, in C# running in the browser. And that's a very good news, because that means your existing code that is maybe calling a microservice using HTTP client is continuing to work. It can use the HTTP client inside the browser. Well, behind the scenes, some interesting stuff is going on because C# running in WebAssembly cannot talk to the outside world. I told you that. So what the Blazor developers did is they created a backend HTTP message handler which does not really send the web request, but it takes the web request, gives it to JavaScript and asks Blazor JavaScript, hey Blazor, would you please send this web request for me? Then JavaScript will talk to the server, will get the result, will marshal the result back into WebAssembly, and there your C# code can handle it. Okay? But still, for you as a developer, it's HTTP client, everything is good. Good. Now then, we have a little bit of a mixture of DOM, as you can see it here, and a little bit of C#. That's the Razor syntax you are probably familiar with. If not, I mean, take a look at the code. It's kind of obvious, right? You have an if statement, and we have a for each statement, and we have some data binding. Yes, we can do data binding. If I scroll down a little bit and zoom in, then you can see here we have ticket.passenger, and here, where do I have it? Somewhere down there should be my ticket. Oh, ticket is here, I'm sorry. Here, tickets, sorry, here I am. As you can see, this is just data binding, okay? I think you can guess what it does behind the scenes. But now comes the interesting stuff. I will zoom in a little bit so I make sure that you can see it. See that one? Get async. Yes, you get async programming modal from C# in the browser. You can do async await. You can do parallel async, so you can run multiple HTTP requests at the same time and use the regular C# syntax for running it. And for me, this little piece of code here with the override and async and await and the existing new .NET Core 3 JSON deserializer, this really is the core value that Blazor brings to you, reusing your existing skills. If you are into C# development, if you have dozens or hundreds of C# developers, if you have many C# artifacts, DLLs, and so on, and you would like to bring them to the browser, you don't need to retrain your colleagues. You don't need to rewrite your software. It's the same C# that you are used to. You don't need to learn TypeScript, and you don't need to learn JavaScript. I think this is one, for those of you who are new to Blazor, this is one of the most important things that you should take with you. Is it the best web development framework on earth? Probably not, because it's so young. Is it a very good solution if you have an existing investment in .NET and C#? Absolutely, because it is exactly the thing that you're used to. Good? Good. Everything else, yes, of course, we have things like link. See that one? Woohoo! Things that we know and things that are really great in C# are now coming to the browser. And this is now doing the HTTP request, as you can see it here. And I would like to emphasize again, I'm using the new JSON serializer. Maybe you have heard it, .NET Core. You don't need JSON.NET anymore for many use cases. You have a new JSON serializer which is much faster, directly built into the framework, and I upgraded my samples recently so that my Blazor is now using this new JSON serializer to benefit from the performance enhancements. Good? Good. Nice. Now, let me quickly check my notes. Everything is fine. We can go the next step. Let's add a bunch of components. Good. Before I talk about the code, let's quickly run the app so that you have an idea in your mind what we just implemented. It hopefully will only take a second or so. So this is our new application. As you can see, again, Optimus Prime, Bumblebee, and Kal-El with a little bit of more detailed information. And as you can see it here, we have a kind of a barcode or a QR code, things like that. This is essentially what we just created. Okay? If I click on it, we get an empty page, and we will add the detail view for the ticket later on. This is not yet implemented. Okay? So now, let's take a look at the code. The ticket list. What has changed in the ticket list? Please take a look at this one. Just like in a framework like Angular, we are extending the HTML element list with custom components. Here on the right-hand side, you see the ticket card, and essentially we are adding a UI component by creating a new Blazor component. Blazor component is the basic building block. So if we want to isolate the logic of every single ticket that we display, we are just creating a new Blazor component. And here we can again use another component, and yes, we can also do data binding, two-way data binding, binding between parents and clients. I will not go into all these details because I only have 60 minutes, and there is a pretty good documentation already in Microsoft Docs. I want to focus on the big picture, not so much on the details that you can read later on. Okay? So remember, here we have really a system for building UI components, structuring a more complex application into smaller pieces, and do, as you can see here, data binding. Let's quickly take a look at data binding, because for those of you who are completely new to Blazor, you may wonder, how does that work? Now, please take a look at this one. Here, we are assigning our current ticket, which goes from here into here, and we are assigning it to something which is called uppercase ticket. If we now take a look at the ticket card down there, you will see that we have in the code section a parameter which is called ticket, and that enables the data binding between the different components. Get the idea? Some of you, I guess, take a look at the code and say, oh my God, is that ugly? We have a mixture of view and logic inside a single file that's feeling like spaghetti code. I don't want to do that. I have a very good news for you. In the latest preview, not in the bits that were released recently with .NET Core 3, but with .NET Core 3.1, Blazor components become partial classes. So if you have an allergic reaction against code and DOM mixed in the same file, wait a few more weeks or months, and then you will get .NET Core 3.1, and then you have partial classes, and then you can put this code into a separate file, and everything is good again. Okay? Up until now, you need inheritance. You need a base class and inherit from it. But I will not cover that because that is history. It will get much, much better. I will show you in a little bit how the generated code looks like. This sample was about data binding and about modular UI. Okay? Good. Let's take a look in a more complex scenario for data binding, and let's take a look at a more detailed view on how the user interface is refreshed. So let's take these ones and copy them again into the pages directory. Yes, I'm fine with replacing this stuff, and I think we can immediately run it. Let's compile it. It will only take a few seconds. Here we are. This is the new version. Very good. And you see now I can switch between past travels and upcoming travels. So Mr. Jake Sully will travel from Earth to Pandora. Mr. John Zoidberg will travel from Earth to Decapod, and Mr. Arthur Dent will travel to Magrathea. For those of you who are into comics, maybe you can recognize one or two names here. Past travels, upcoming travels, and I would like to focus on how I implemented this switch here. Okay, this is the thing that we are now looking into. Good, let's stop this guy and take a look at the ticket list. As you can see it here, I have this time selector. Again, it's just a component, nothing special, but this time I would like to draw your attention on this thing here, bind time. This @bind time means I'm binding two-way. This is a two-way binding from the parent to the child and from the child to the parent. This is how two-way binding is implemented in Blazor. So if we take a look at the time selector here, you will see that this is just regular DOM, and we do a little bit of event binding here on click. We would like to call a method if the user clicks on a button. I think you can guess the details from the code. And at the end of the time here, we again have the time parameter. And in my case now, the parent is two-way binding on the time. So whenever the child, the selector, changes this entry time, it will automatically notify the parent the display of all the tickets, that something has changed and we have to fetch new tickets. Get the idea? So that's the idea here. That is how two-way binding really works. So if something happens, our setter is called. You see, we are setting the time past or future travels, and then we are using a method refresh tickets, which does nothing else than doing an HTTP request, fetching some tickets from the API. It's really not very interesting. The interesting thing comes here. Blazor is pretty intelligent in detecting when to update the UI. But in this case, I have selected a kind of code where I'm doing a two-way binding, and in the setter I'm doing some HTTP requests. To make a long story short, Blazor will not automatically recognize that something interesting has changed in our C# code so that the user interface must be repainted. It didn't recognize that. In such cases, you must help Blazor, and you do that by calling state has changed. State has changed is a method provided by Blazor where you say, hey Blazor, my state has changed, please find out what to draw on the screen. Now what happens with all these user interface interactions? I would like to show you one slide that I'm particularly proud of because it has so many animations on it. It took me longer than creating the code. No, I'm just kidding. Remember what we have. We have the web server here with our WASM and DLLs and so on, and we have the browser. So what's going on with all this data binding stuff? The first thing, the browser loads the application. Nothing special, HTTP GET, and it returns some HTML, JavaScript, CSS, DLLs, WASM, whatever. Next, the DOM is built from the index.html, and that triggers Blazor JavaScript and Mono JavaScript. We talked about that. The Blazor and Mono JavaScript will load the Mono runtime in the form of WebAssembly. The Mono runtime will spin up .NET and Blazor, and .NET will spin up your app. It's just a DLL. Just a DLL that you can run everywhere, okay? So, here we have the WASM part, and on the right-hand side we have the JavaScript and DOM part. So, if the user, for instance, we have the startup of the whole application, it calls into the app, initialize yourself, and then something is printed on the screen. Now the app can do some UI refreshes, nothing special here. Now comes the interesting part. If the user clicks on the DOM here, if he clicks on the DOM, the event is handled by Blazor, not by your application. So the on-click in your C# is not directly called by the browser, but the browser will trigger Blazor, and Blazor will then go through the whole stack again. It will call Mono, Mono will call .NET, .NET will call your app, and in your app you will react on the button. You get the idea? That's the whole thing here, what's going on behind the scenes. And if you want to do a web API call like with us, which switch between past and future, your app is talking to Blazor JavaScript is talking to the web API, the result comes back and everything plays on again. Get the idea? Good? Fine? Nice. Yes, we can share C# modal and logic because we have C# here and we have C# here. So if you have business logic that you would like to run on the server in your web API and you would like in your front-end application, you can absolutely do that, and I will show you that in a bunch of minutes. Good. I have a second one, and I would like to talk about that one. Exactly. That's a little bit simplified, and now we go more detailed. We dive deeper into the data binding stuff. On the left-hand side, you see DOM, JavaScript, Blazor, and the app. So if the app, for instance, would like to display something, it talks to Blazor. Blazor creates a so-called render tree. What is a render tree? A render tree that Blazor maintains is an internal data structure, which is a kind of logical representation of the document object model in the browser. It's a C# version of your DOM, and we call it the render tree. This render tree is sent as a render batch, which is essentially a list of commands. Please add this paragraph, add this button, and so on, is sent to Blazor, and Blazor will then execute this batch and change the DOM accordingly. Then we have something on the screen. If the user clicks in the browser or the app decides to change something on the screen, it really, in the back end, changes the render tree. As you can see it here, it adds something in its C# representation of the DOM. Blazor will recognize that something has changed and it will create an appropriate render batch. It will not repaint the whole UI, it will just create a render batch changing a single piece in your DOM. And this render batch will then be applied to your DOM again. This is how it works behind the scenes. Okay? Good? Fine? Good. This is what I wanted you to see. Next one. Inhale, exhale, next topic. Router. Let me quickly check my notes. Okay. Let's take these two things and add it to the pages here. And again, run it. It will compile everything, do the NuGet restore or whatever. And finally, I would like to show you what we have achieved now. Again, we have our list of tickets, everything is fine, but let's take a look at the details of the ticket of Optimus Prime. Click on it. Oh, I see. Now we have a detail view about the ticket for Optimus Prime. Please take a look at the URL up here. It's a classical single-page app URL, so we see the ticket ID of Mr. Optimus Prime, and he traveled from Cybertron to Earth on July the 4th, 2007, and it was a pretty cheap ticket here that he got, pretty good. Or let me take a look at, I don't know, maybe Mr. Jake Sully. Okay, he traveled from Earth to Pandora in 2000, or he will in 2154. So how is this detail page created? Let's take a look at the code. If we take a look at the ticket details, then you will see how the router works in Blazor. Essentially, it's pretty simple. You just add some curly braces as you're used to from ASP.NET Core, and this ticket ID, please remember the name ticket ID, is then written to, again, a parameter down here, whoops, ticket ID. So this receives the parameter, okay? If we get the ticket ID here, we will do some interesting stuff, and I would like to point your attention to this one. Please recognize that we are running two asynchronous tasks in parallel by using a task when all. I hope that many of you are familiar with C#, so we are not awaiting each task, we are starting two HTTP requests in parallel. Does that mean we have parallel programming in the browser? I mean, JavaScript is single-threaded, right? Suddenly, magically, C# is adding multi-threaded capabilities to browser? Unfortunately, not. But we can do parallel non-blocking I/O. We can do that. So you can do multiple parallel HTTP requests, but you cannot do CPU-bound things in parallel. So the good thing with parallel 4 and so on, it still doesn't work in the browser. Theoretically, maybe at some point in the future, service workers and so on, maybe, but currently, absolutely not a thing. The browser is and stays single-threaded, also with C# in the browser. This is what I wanted to point out here. Good? Now let's quickly take a look at the ticket list here. No, it's in the ticket card, sorry, here. Then you will see that adding the link is really, no, it is in the ticket list, sorry. Adding the link is really simple. Time select, no, it's in the ticket card. Where is it, where is it, where is it? Then it's in the QR code. And finally I found it, as you can see it here. If you want to do a link, you just use an anchor href here. But the link target is again read through dependency injection, through data binding, okay? So any Angular developers in the room, router link, things like that, you don't need that. This is done automatically by Blazor. Just use an ahref and everything is fine. It is really a single page call, okay? It's not loading anything from the server. So this is how routing works with Blazor. Ready to go a little bit deeper? And then let's take the next level and take a look at the Razor compiler and what it does. So let me add my, where am I? Here we are. My flight network and my network Razor, it should go here. Good. And the flight plan, I will show you the code in a second. I think it should go into modal. Yes, that's right. It should go into modal, exactly. And finally, I think, nope, small thing. In the client, we have a startup, and as you probably know, dependency injection. I will not go into the details. You probably recognize this code with configure services and configure. I just say services.add singleton. Flight plan, and we have an implementation flight plan. This is how it should look like, and that's it. Good. Again, I will run the code, and then we will take a look at the details of the code. It's compiling. Now we will really take a look behind the scenes, what's going on behind the scenes. Let's run it. I forgot obviously something. What did I miss? Okay, here, flight network. Okay, it was just not ready. I think it should work. No. What's the problem here? 0 errors, build failed. I love that. Let's do a rebuild. It's preview bits. Yeah? It's really 3.1 and preview and latest and so on. So sometimes it's okay to have a small hiccup. Should be done in a second. Come on, build it. So I don't want to see these warnings. Okay. Now it looks better. So let's go to the flight network. And as you can see here, I'm visualizing the flight network in a kind of network graph, and I can hover over it, and I have nice little animations, a little bit of CSS magic, nothing special here. But the point that I would like to make here is that in this case, let me zoom in a little bit, this whole visualization that you see here is driven by an algorithm. I didn't paint all the pictures here, but I have a site, I have a DOM, I have a render tree which is built really driven by an algorithm. I'm using a little bit of angle functions, sinus, cosinus, and things like that to calculate the dots and to draw these Bezier curves and things like that. So that is the demo here that I created for you. So let's take a look at the code. And first, before we take a look at the nice flight plan that I implemented, I would like to show you what Blazor really does behind the scenes. Let's take a look into our object directory, debug, net standard, Razor, pages, and so on, and there we will recognize a bunch of generated files. Interesting. Let's take a look at the ticket list here. So let's open the ticket list. This is the code that Blazor generates from your Razor pages. If I scroll down a little bit, we will see that from our ticket list component, we will get a class. And things like routes and dependency injection and so on are modeled as attributes. So what we get from a Razor file is a C# class with a bunch of attributes applied to it and which derives from the base class component. That is essentially what's going on behind the scene. And now if you take a look at the content of this class, you will recognize a method which is called buildRenderTree. Can you remember what a render tree was? It was this logical representation, this virtual DOM in the C# world, which reflects the DOM in the HTML world. Okay? So what we essentially do is we are building the render tree from our Razor code. So let me quickly show you the Razor code here, side by side. Come on, Visual Studio. This one, and let's put it here. And let's make it a little bit larger, and let's scroll a little bit. Now, please take a look here. H1 div, here you have the H1, here you have the div. Then we have some markup content, maybe down here we have an H2 loading your tickets. So you see from this Razor page, the system created the buildRenderTree method with a bunch of attributes and nice things. This is done automatically by the Blazor compiler. If we take a look at the project file, then we will see here that we have the Razor SDK, and this SDK contains the Blazor compiler, and this Blazor compiler, Razor compiler, compiles the Razor files into C# classes. And if we want we can forget about the whole razor stuff and do the whole process on our own. And this is what I did here. What I essentially did is I hand wrote the build render tree method, and I'm creating the entire user interface based on an algorithm. So I'm calling, and this is a documented API, I'm calling methods like open element, add attribute, open element, close element, and so on. I'm calling it manually if I need to create views which are driven by algorithms instead of markup. Get the idea? That's pretty powerful. It still supports data binding and all this stuff. It still works. Yeah? And that's pretty cool. Understand it? What's going on behind the scenes? Yeah? Fine? Good. The next thing that I would like to point out is that the whole business logic of doing the calculation and the whole math stuff, if you're interested in, you can check my code on GitHub. The whole math stuff is of course not implemented in the Blazor project. Instead, I put it into a .NET standard class library, which I can use for any kind of application that I want. Maybe I need to generate this nice little graphic for a printed magazine that we make available in our spaceships. Then we can use exactly the same algorithm in a command line tool, which generates a bunch of static images. Get the idea? So still, don't add your business logic to your front-end projects, but use .NET standard libraries. And that also works in the other way around. If you already have .NET standard libraries with business logic in it, you can use it. You can still use it here and reuse it and don't need to rewrite them. Got it? You will see a demo about that in a few more moments. Last but not least, you probably have already recognized a good friend of us, dependency injection, just like you are used to in ASP.NET Core. Really works nicely. Good? Good. Next one. Forms. Let's add a new page here and run it. Compiling. Good. Running. Nice. Now we have the third one here, book ticket. Now we can really book a ticket. So let's fly Mr. Luke Skywalker, maybe, I don't know, from Tatooine to Earth, for instance. Now let's make consciously a mistake, okay? Let's just call him Lou, not Luke Skywalker. This is wrong. Our modal says that the name of the passenger must be at least 5 characters long. I just came up with this to demonstrate it. So if I click submit, I will get an error as you can see it here. Let's take a look how this is implemented. First, good news is that in recent versions of Blazor, you got a brand new data form validation modal. So what you essentially do, you're replacing your HTML form with an edit form. And then you can assign a modal. You see it here. A ticket is a class from our modal.NET standard DLL. And maybe you can already guess what's in my ticket modal. Let's take a look at the ticket. Ticket is here. See this one? Data annotations attributes. So the data annotation attributes that you maybe use for entity framework and maybe have already used for data binding stuff and for your server-side ASP.NET Core modal validations, for your web APIs and so on, they continue to work. They continue to work as expected. And I think this is pretty powerful because now we have data annotation attributes and they are used by the web API and the front end. So if I take a look at the book ticket stuff here, then you will see I never anywhere check that the passenger name must be at least 5 characters. It's not necessary because this is done automatically by the edit form and the data annotations validator. It's using data annotations as the name suggests, and to display the validation summary, I just add another component. Of course, I can manipulate that and I have a lot of possibility to customize that to my specific needs and to format it and things like that, but it is a great news that we still can use the data annotations attributes. Because, and I would like to point that out, in my API, if I take a look in the API solution here, tickets controller, then you will see that here my posting the ticket, see that one here, is doing nothing for validation. Why? Because ASP.NET Core does that out of the box. If you write a controller base with an API controller attribute, it will automatically take a look at the modal, recognize the data annotations, and will throw back a bad request if something comes in which is not okay. And with that, I can reuse my modal validations on the server and on the client. Want to have proof? I can show you proof. So let's quickly send manually an HTTP request. Where is it? Here, requests. As you can see it here, passenger is not there. If I send it, this is the backend, see? If I send it there, I will get back an error. This is from the API, and these are the validation errors on the backend from my data annotations. Yeah? Get the idea? And if you use these modals maybe directly for Entity Framework, it will automatically create the not null statements and so on also from a single .NET standard class library. I think when I discuss that with some customers, some don't feel comfortable with that. They say, oh, that is too tightly bound to each other. Haven't we heard about microservices, that microservices and micro UIs, they should be separated? They should only be loosely coupled, and we don't want to mash them together. I agree. But if we work in a backend for front-end architecture, where we have a backend which is specifically designed for a certain front-end, then it makes absolutely sense to reuse code, because we have the front-end, and we have the backend for front-end, and in many cases, both elements are developed by the same team, or at least by two teams sitting near to each other. We are not talking about the backend microservices, which might be written in a completely different language. If you visited my previous talk about Go, then maybe this is the right thing to implement a backend microservice with. I just wanted to make that point. Please don't be angry with me if I take questions at the end, okay? Because I have a very tight schedule and I would like to finish everything, and then I will take a look at the clock here, and then we can take questions, okay? Good? Understand the idea of data validations and form validation and so on? Good. Now, what about JavaScript? I'm always talking about existing libraries and existing stuff in C#, but I guess many of you use already C# on the back end, but you have some investments in JavaScript too. Is this investment lost? Well, luckily not. So my book ticket, where is it? Here, book ticket. Yes, new book ticket. And my flight plan is also updated in this one. Good. Fine with that. Now, let me quickly show you our index.html. Here it is. And as you can see it here, I added a little bit of JavaScript in my index.html. This is really trivial, okay? I just added two functions here, a confirm function and an alert function, and it calls window.conform and window.alert. Please use your imaginations. Here you can add as many functions and as complex functions as you want. It can be whatever entry to your big JavaScript library, which does awesome things on the client, displaying great charts and whatever. I don't care. For me, I want to keep things simple. The important thing is that we register our JavaScript at a single object inside the global namespace. So window.starship_travel, this will hold all our functions that we call from C#. Now, if we take a look at the base image, the book ticket here, then you will see up here that I'm injecting something new, which is called i.js runtime. The i.js runtime, in that case, is really the bridge towards custom JavaScript. It goes into two directions. From C#, you can easily call a JavaScript function, and from JavaScript, you can easily call C#. I will not demo that one. So in my case, I would like, in C#, display a message box using JavaScript code. This is what I do here. Let's take a look how complicated that is. And essentially, it's absolutely not complicated. You see it here. All you do is JS runtime, invoke async, starship travel.alert. That's all you have to do. So it's looking, please remember, starship travel.alert. So it's looking for a global object here, starship travel, and looks up the function alert here and calls this JavaScript. And again, use your imagination. This can be any kind of JavaScript that you have already written and you would like to continue to use inside of your Blazor app. Get the idea? This is how JavaScript interop works. Now, you know, I wanted to make this application a little bit more interesting. And therefore, I thought if we remember, do I still have it online here? Yes. If we remember, for instance, the travels from Earth and so on, then we can, for instance, see that from Tatooine to Earth, we don't have a direct connection. So if you would like to go from Tatooine to Earth, you have to travel from Tatooine to Krypton and from Krypton to Earth. Yes, I know that Tatooine and Krypton belong in two different universes, but in my example, I really put them together. So if we want to let Luke Skywalker travel from Tatooine to Earth, he has to travel through Krypton and maybe can visit his friend Superman or whatever. Now we have to find the shortest way through our network of Starship connections. I could implement this by hand, but I didn't want to. What I did is I went to NuGet and I was looking for an algorithm which is called Dijkstra. Dijkstra is a pretty famous algorithm for shortest path analysis, and it turns out there is a .NET Standard library which can do shortest path analysis based on the Dijkstra algorithm. I would like to use it. Now imagine this is your existing business logic. This library was never written for browser. It was never written with Blazor or WebAssembly in mind. It's a plain old .NET Standard DLL that I happen to get from NuGet. So if we take a look at our modal here, then you will see that I'm registering Dijkstra.net. That's just the .NET Standard library from NuGet. And this could be your business logic. And inside of my flight plan here, I'm using the Dijkstra library without any special things. So with that, we should now be able to do a shortest path analysis from Tatooine to Earth using a .NET Standard library and displaying the configuration message in JavaScript. This is what I want to do now. Let's see if it works. Let's run this guy. Here we are, book ticket. This time, we really let Luke Skywalker fly, and we fly from Tatooine to Earth. We click on submit. We click on submit, and nothing happens. Oh my God, what did I do wrong? Good, oh, I didn't refresh it. I'm sorry, I didn't refresh it. Good, again. I think I had an old version where I didn't copy the code already. I'm sorry. Let's try it again. Nope. So let's close a few windows here. Close, close, close. I'm sure I will be able to do that. So .NET, close this one, and rerun it. Sometimes I have to do a rebuild because by copying old files into the system, sometimes Visual Studio doesn't recognize that it should rebuild a certain DLL because the file dates are not okay, and therefore I will do a rebuild all and run it again, and hopefully it will work then. We still have 10 minutes left, so we are good in time. So let's give it a try. Here we are, book ticket, and Luke Skywalker from Tatooine to Earth, and let's see, yes, this is exactly what I wanted to see. You see, where it doesn't look very spectacular, but from my point of view, it is spectacular. Because this message box is displayed using JavaScript interop. We called from C# running inside of WebAssembly mono through Blazor JavaScript, an existing JavaScript snippet that displays the confirmation box. And the content of the message, Tatooine Krypton Earth, was calculated using a Dijkstra business library with a shortest path graph analysis that found that the connection between Tatooine and Earth goes via Krypton. So it might not seem that interesting, but it is pretty powerful if you live in a world where you have a lot of existing business logic in .NET and also have some visualizations in JavaScript, and you now would like to conquer the browser because up to now maybe you were living in WPF or WinForms land. Got the idea? See why this is, for many companies, pretty exciting? Okay. Good. I have 2 demos left. 10 minutes, very good. That's exactly what I need. The next one is the API service. Let me quickly copy some files here. Oops, here, and I will show you the content of the files in a second. This one and a little bit of pages here, and yes. It looks like a lot of code, but it's only minor changes, but I didn't want it to make it small. This one. Exactly. So let's rebuild it, and in the it doesn't change any visualization. It's just an internal application change. I would like to show you this one. I now created an interface. Please note that it's in the modal and business logic library. It's just .NET Standard. I created a library which is called an interface which is called iStarship API. This iStarship API offers me some central helper functions with which I can call my web API. If we take a look at the implementation of this interface, then you see I'm just using the HTTP client and I'm using .NET Standard code to do HTTP GET, to do JSON serializing, and so on, inside a class library. Get it? Now, if we take a look at the Starship Traveler client, we can now configure this guy. Again, iStarship API with the Starship API. Starship API. This is it. I'm missing a using here. Let's add the using. Here it is. And the implementation in Blazor looks like this. The important thing is that if we are in Blazor, we can add for a pre-created HTTP client through the constructor and just say, please give me an HTTP client, which is automatically wired up through JavaScript with the browser. But the majority of code, the whole HTTP client with which I can access backend microservices, is written once in a .NET Standard DLL. I don't need to copy the code, and I don't need to re-implement anything. All I need to do is I need to provide the HTTP client that Blazor gives me to my standard class library, and then everything works the same. So in a world today, at least in my projects, I often have a situation where I am calling a backend for front end, and then I have dozens of microservices in the backend. And this is exactly the code that I would like to see. I would like to implement a .NET Standard library, and I can use it in the front end, in the middle tier, in the back end, wherever I have C#, I can reuse this code. Get it? And dependency injection is building the bridges between the different worlds. Let's see whether it works. Let's run it. It should still display the same data. That would be a success if we still see some data. And yes, we still see data. Everything works as expected, but now through a central API service. Good. Last demo. The last demo, I will copy a little bit more code. No problem. Here. I will copy this folder, and I will tell you in a second what this folder is all about. It's an existing project. And I will add it to the solution. Add existing project. And I am here. Server side, this one. Good. And let's set it as the startup project. And let's call it. It's just 3 very small files here. And looks exactly the same, right? Book ticket. Let's see if Luke Skywalker traveling from Tatooine to Earth still works. The whole JavaScript stuff, everything works nicely, nothing special. Nothing really happened. So let's take a look behind the scenes. Let's go to network and reload this guy. And take a look at this one. Can you find WebAssembly here? Well, no. That's the point. What I now did, I added a very, very small project. It consists of 3 files, and the index.html is a little bit different, and the startup code is different. Everything else is consuming the class libraries that we already created. And this is called server-side Blazor. What is going on, and where is WebAssembly? I would like to use my last slide that I'm proud of today. So now we have a different picture. We have ASP.NET Core 3 in the background. We have the core CLR, no longer mono. We have Blazor running on the server, no longer in the client. We have our app running on the server, no longer in the client. And on the browser side, yeah, of course, we have the whole startup stuff. On the browser side, we only have Blazor, JavaScript, and DOM, not our own code. Nothing of our own code. Now, what's going to happen is that the Blazor JavaScript part opens up a WebSocket SignalR connection to Blazor on the server. And now the entire thing with rendering the HTML, and then the whole, let me quickly go over that, the whole building of the render tree, the sending of the render batch is not done from WebAssembly to JavaScript, but now with this thing, it's done on the server and sent via WebSockets to the client. That means we don't need WebAssembly on the client, we don't need the mono CLR on the client, and therefore we have fully supported pieces of code, and this is not preview, this is ready for production. So what I would like to show you here is with server-side Blazor, and it's really only a minor change. Everything else applies. All the code that I've shown you works in the server-side part too. So it's really easy to learn. You can switch with server-side Blazor between running your logic on the server and running your logic on the client. Think of what that means for maybe old browsers that don't support WebAssembly well. They can go through this one. Think of a client which is not very powerful. You can go through this one because then you run all the services on the background, on your servers in your ASP.NET Core 3. Think about some drawbacks of Blazor. Blazor, for instance, on the client doesn't have a very good debugger support. Here, we're using the full ASP.NET Core debugger. You can set a breakpoint. You can even go one step further. I mean, it's maybe not the best idea, but you can do it from your Blazor pages, directly access a database. Why? Because your Blazor, your Razor page is now running on the server, and it can, if it wants, directly use Entity Framework to directly access the database. Doesn't mean you should, but you could, you know? With big power comes big responsibility, to stay in the comic theme here. So think about it. But to be honest, sometimes we have to ship code. And if I am in an enterprise environment, and if I have very limited budget, and I have to ship something today, and I want to reuse .NET, and I don't have the possibility to re-implement everything with JavaScript, TypeScript, Angular, Vue, and so on, maybe this is exactly the tools that leads me towards my goal. Yeah? It's maybe a shortcut, but it's a very valuable shortcut. Okay? So server-side, I can show you quickly in the last few minutes the differences. You see, the dependency injection looks a little bit different because now we have fully blown ASP.NET, but still our services are exactly the same, nothing duplicated. Yes, in the index.html, it looks a little bit differently. If you take a look here, it says blazor.server.javascript, while in our good old index.html up here, it says blazor.webassembly.javascript. But these changes are really minor. 99% of the code that I showed you are identical, and now we have 2 variants of our software, one using WebAssembly and one using the server. As I said, the server version is available today. It's fully supported. It's out of preview. It's RTM. You can use it with ASP.NET Core 3. The WebAssembly stuff is still in preview, and you will have to wait until spring, summer 2020 until this becomes generally available and fully supported for production use. With that, my time is off, and also my demos are ready. So I'm very glad that it worked out. If these two things come together in a talk, you're done with your demos and you're done with the time, then it's a relief. I hope it was interesting this hour. I hope this approach of not showing you many slides, but showing you a non-trivial application step by step was somehow inspiring, and you got some knowledge from this, and now you have a closer picture in your mind what Blazor is and what Blazor isn't. I would like to close here in the official plenum here, so I want to say thank you for those of you who came. If you have any questions, please come to me to the front. I will be more than happy to answer all your questions if you have some for Blazor. Thank you for coming here, and take a look at the video once it's online. Thank you.